Day 748 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3043. Find the length of the longest common prefix. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go on and check out that link in the description so you can get you some. Now let's see what the question says. You are given two arrays with positive integers R1 and R2. A prefix of a positive integer is an integer formed by one or more of its digits, starting from its leftmost digit. For example, 123 is a prefix of the integer 12,345 and 234 is not. A common prefix of two integers a and b is an integer c such that c is a prefix of both a and b. For example, 5655359 and 56554 have common prefixes 565 and 5655, while 1223 and 43456 do not have a common prefix. You need to find the length of the longest common prefix between all pairs of integers x, y such that x belongs to R1 and y belongs to R2. Return the length of the longest common prefix among all pairs. If no common prefix exists, return 0. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have R1 equals an array of integers 1, 10, 100. R2 equals an array of integers 1000, and the output is 3. So, let's break that down so we can see how we got this output from this input, right? It says there are three pairs R1 and R1 of I and R2 of J. The longest common prefix of 1 and 1000 is 1. So this 1 is a prefix of 1000, right? Because it's a 1 right here, but it only has a count of 1. Boom. Then it says the longest common prefix of 10 and 1000 is 10. So this right here, this 10 is also a common prefix of this 1000, right? It has this 10 right here prefix, this prefix 10 right here matches this 10 right here. And this only has a count of 2. Boom. This 100, boom, it says the longest common prefix of 100, 1000 is 100. So in this case, 100 and 1000, or excuse me, 100 and this 100 prefix in the 1000, this right here, matches this 100 and it has a count of 3. So since this is the longest common prefix is 100 with a length of 3, we return 3. So since this right here has 3 digits, right, the prefix is 3 digits long, and that's the longest one, then the output is 3. This prefix only has 2 digits, and this prefix only has 1 digit. We want to return the length of the longest common prefix, right? And the longest common prefix in this case would be 100 with a count of 3 digits. Boom. So just in case that didn't make sense, let's take a look at example 2. So in example 2, our input R1 equals an array of integers 1, 2, 3. R2 equals an array of integers 4, 4, 4. The output is 0. Explanation says there exists no common prefix for any pair R of I and R of J hence we return 0. Note that common prefixes between elements of the same array do not count. So as you can see in this array, they're all single digits, right? And both arrays are all single digits. Sorry about that. Both arrays are all single digits and they're all different digits, right? These digits in R1 are different from the digits in R2. And since they're all single digits, then there's no way for any of these to be a prefix of any of these. So since that's the case, we return 0, y'all. Boom. And I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we're going to do is we're going to create a variable that stores the maximum prefix length so far. So we'll declare a variable called res, and we'll set that equal to 0. Now we need the lengths of both arrays. So we're going to say let n equal r1 dot count, and we're going to say let m equal r2 dot count. Boom. Now we're going to use a set to store all possible prefixes from R1. So we'll declare a variable called set. We'll say colon is going to be a set less than and greater than a set of integers, and we'll initialize it with a blank array. Now we're going to iterate through every number in R1. So we'll say for I in 0 dot dot less than n. We'll open up the brackets and we're going to start with the full number. So we'll say declare a variable called num, and we'll set that equal to R1 square bracket I. Boom. Now we're only going to process the number if it hasn't already been added to the set. So we're going to come over here and we're going to say if exclamation point set. So dot contains, and this exclamation point lets us know if set does not contain. We're going to open up the parentheses, pass in num, come outside of those parentheses, open up the brackets, and we're going to continuously remove the last digit to generate every possible prefix. So we're going to say while num is greater than 0, we're going to open up the brackets and we're going to store the current prefix by saying set.insert, open up the parentheses, pass in num. Then we're going to remove the last digit by saying num divided by equals 10. Boom. But we're not done yet, because we still need to iterate through every number in R2. So we're going to come right here. Sorry, y'all, hold on. We're going to come right here. Sorry about that. And we're going to iterate through R2. So we're going to say for j in 0 dot dot less than m, we're going to open up the brackets and we're going to start with the full number by saying declare a variable called num, set that equal to R2 square bracket j. Then we're going to come underneath that and we're going to count the number of digits in the current number. So we're going to declare a variable called total digits, set that equal to an int, open up the parentheses, log 10, open up more parentheses, double, open up some more parentheses, ABS, open up some more parentheses, pass in num, come outside all 4 of these parentheses and say plus 1. Boom. Now we're only going to continue if this number could possibly improve the current best result. So we'll say if total digits is greater than res, then we'll open up the brackets and we're going to keep removing digits from the end to check all prefixes. So we're going to say while num is greater than 0, we're going to open up the brackets, and if this prefix exists in R1's prefix set, we found a common prefix. So we're going to say if set.contains, open up the parentheses num, come outside of that, we're going to recalculate the number of digits for the current prefix by saying var total digits, set that equal to, once again, an int, open up the parentheses, log 10, open up the parentheses, double, open up the parentheses, ABS, open up the parentheses, pass in num, come outside of that and say plus 1. Boom. Then we're going to update the maximum prefix length found by saying res equals max, open up the parentheses, res, comma, total digits. Boom. Now we're going to remove the last digit to move to the next smaller prefix. So we'll come underneath this, declare num divided by equals to 10. Then we're going to decrease the digit and count accordingly by coming underneath this. We're going to say total digits minus equals 1. Boom. Then finally, we're going to return the length of the longest common prefix found by coming down here. And we're just going to say return res, y'all. Boom. That's all she wrote. Let's give it a run. Make sure it runs properly before we submit it. It's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Boom, and look at that, y'all. 71 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the middle. This is the bottom, y'all. And yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.